Hi, it's Bruce, and welcome once again to my Colorado Rocky Mountain lab. And at the moment, what we're looking at is a project that I built using a wideband amp that I picked up on eBay. This one is 500 kilohertz to 1.6 gigahertz wideband, 50 ohm output. Came as a little module. Expected you to give a voltage to it. In this case, let's see. Our voltage on this is 12 volts. I happen to have a 12 volt wall wart on hand, so I'm supplying 12 volts into the back of the unit. I went ahead and just drilled a hole right in there and tied a knot on the inside so it wouldn't pull out. And figured in a lighted switch so I knew when the thing was on. Mounted it to the case in there, and voila. Produced some labels using my little Dymo label maker on clear tape. And right now I am feeding in a 200 hertz, a 200 megahertz signal from that HP. That 200 megahertz signal is coming in, and I'm splitting off of the input, and I'm looking at the input on channel B, and I'm feeding the input into the unit, and then the output of the unit is going into channel 1. And okay, as we can see right now, we have on channel 1, we're feeding in 0.1 volts per division. So we got 0.1, 0.2, 0.3, 0.4. On channel 2, we're coming in at 10 millivolts per division, and we're only going up 1. So we're going from 10 millivolts to 0.4 volts, which would be 400 millivolts. So that'd be a gain of what, 40? Sounds like it. So we're getting a gain of 40 at 200 megahertz here. Okay, so I've opened up the case of the wideband amp just to give a look at the inside of it. Basically, that's the amplifier module that I bought there. The input, the output, the power lines on the back. Mounted the switch in the front panel. So I bring in the wall wart, bring one side of the wall wart to the switch, the other side of the switch to the power module. Then the ground side of the power or wall wart goes to the ground side of the module. Then I hooked on the short connectors, which I put to the bulkhead adapters. Anyway, so that really is basically all there is to it. I drilled a couple holes in the back and put a strap on to hold that little case back there because there was no mounting screws or anything on the case. So pretty much it. Okay, so here we've attached the input of the simometer or counter, frequency counter, to this wideband amplifier, which is another project I'm going to display in a later review. But this project will amplify signals between 0.5 to 1.6 gigahertz, so 0.5 megahertz to 1.6 gigahertz. And right now I'm feeding in a signal of a gigahertz, and we can see that we're reading that without a problem. And if I up my frequency here, let's go to 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. Now the 1.6 is the limit of my wideband amp's specified range. So I don't know that we can go more. We'll try 1.7, 1.8, 1.9. There's 2. So it looks like we can just about get to 2 gigahertz, but we're overdriving that wideband amp, so probably not a great idea. Put her back down to 1600 here, and then I feel safe. But at least I proved that the counter is capable. It just doesn't have sensitivity. So it really needs an amplified front end. Okay. So anyway, a handy little unit to have on the desk, on the bench, if you need to amplify something that is too low in value, but yet still critical for whatever you're looking at, so you want to amplify it. Simple project, thought I'd give you a look. Thanks.